Hi learners! Welcome to Math is Fun with Sir O. Today, I will be discussing trigonometric functions. Before we go to our discussion, I'm going to read first our learning objectives. At the end of this lesson, the learner should be able to first, familiarize the 6 trigonometric functions. Second, learn how to use these trigonometric functions to calculate the unknown sides or angles of a right triangle. And lastly, apply the concept of trigonometric functions in real-life situations. Before I introduce the 6 trigonometric functions, let's define first trigonometry. What is trigonometry? According to Britannica.com, trigonometry is the branch of mathematics concerned with specific functions of angles and their applications to calculations. Trigonometry developed from a need to compute angles and distances in such fields as astronomy, map-making, surveying, and artillery range finding. It is also defined as the study of triangles, specifically relationship between sides and angles of a right triangle. Trigonometry studies the relationships between the side lengths and angles in a triangle. On the picture, we have here our right triangle. A right triangle is a triangle whose one angle is equal to 90 degrees and we have two acute angles. The longest side of our right triangle is the hypotenuse and the shorter sides are the legs. And of course, with respect to this A here, it is our angle. In relation to angle A, the sides of the triangle are, first, hypotenuse. It is the longest side and side across from right angle, which is 90 degrees. The next side is our adjacent side. It is the side closest to angle A. And the last side is opposite side. It is the side opposite to angle A. Now for us to have a short recall of the names of the sides of our right triangle, let's label the sides for angle B. Which side is the hypotenuse? That's right. So this is our hypotenuse. This is the longest side of our right triangle. How about adjacent side? Very good. So this side here is our adjacent side because it is the side closest to angle B. And which side is the opposite? That's right. So this is our opposite side since this side is opposite to angle B. The ratios of the sides in relation to angle A are what we call our trigonometric functions. We have 6 trigonometric functions or ratios. We have sine, cosine, tangent, cosecant, secant, and cotangent. Actually, we don't need to memorize these 6 trigonometric functions. 3 of the trigonometric functions will be enough for us to solve for the missing values of the sides of a right triangle or even the angles of the right triangle. Now, the basic ratios that we are going to memorize are TOA. So let's discuss TOA. For us to be able to memorize TOA, we're going to put a word to represent each of the letters. For S stands for some, O stands for old, H stands for hippie. For C stands for came, A stands for and H stands for happen. And TOA, T stands for through, O stands for hour, and A stands for apartment. Now you can chant these words. So katawa, some old hippie came a happen through our apartment. Now repeat after me. So katawa, some old hippie came a happen through our apartment. Now it's your turn to chant these words. Good job. Now let's familiarize Sokatoa. So that would be SOH. The first letter there is S. That stands for our trigonometric functions sine. And the corresponding ratios will be O and H, which means opposite and the hypotenuse. Now with respect to our angle A, so that would be sine A is equal to O, which is opposite side, divided by H, which is our hypotenuse. So sine A is equal to opposite divided by hypotenuse. Next we have CAH, C-A-H. The first letter is C. That stands for the trigonometric functions cosine, and the corresponding ratio, which will be adjacent side and the hypotenuse. So with respect to angle A, that would be cosine of A is equal to adjacent side divided by its hypotenuse. Then we have our TOA, TOA. The first letter T is our trigonometric function, which is our tangent. And then the corresponding ratio would be the opposite side and the adjacent side. Now with respect to our angle A, tangent A is equal to opposite side divided by adjacent side. And so that's SOHCAHTOA. Now let's recall our sine. So we know that sine is equal to opposite divided by hypotenuse. However, if we're going to get the reciprocal of sine, then we have our next trigonometric functions, which is cosecant. So cosecant with respect to angle A is equal to hypotenuse divided by the opposite side. For cosine, if we're going to interchange the positions of adjacent side and the hypotenuse, then we have another trigonometric functions, which is the reciprocal of our cosine. That would be secant. So secant with respect to angle A is equal to hypotenuse divided by its adjacent. Then we have our tangent. So if you're going to interchange the positions of opposite side and adjacent side, then the six trigonometric functions will be cotangent. And cotangent with respect to angle A is equal to adjacent side divided by its opposite side. Now, after we have already familiarized the six trigonometric functions, this time we're going to solve for the values of the sides of our right triangle and the angles of our right triangle. So for any right triangle, we can calculate the other sides if one side in the angle are known. Also, we can calculate the angle if two sides are known. And lastly, we can also calculate the side of a triangle if two sides are known using Pythagorean theorem. Let's have an example for this. Calculate the other side of the right triangle using Pythagorean theorem. Let's recall the formula of the Pythagorean theorem. That is, the sum of the squares of the two shorter sides equals to the square of the longest side. In other words, that would be the sum of the squares of the opposite side and the adjacent side is equal to the square of our hypotenuse. In our illustration, the unknown side here is our b. From our formula, we could be able to derive, and that would be b squared is equal to c squared minus a squared. In our given, we have a is equal to 4, which is the opposite side, and c is equal to 5, which is our hypotenuse. Substituting these values to our formula, so we have b squared is equal to 5 squared minus 4 squared. Then b squared is equal to 5 squared is equal to 25 minus 4 squared is equal to 16. Then b squared is equal to 25 minus 16 is equal to 9. Then we take the square root of both sides of the equation, and that would be the square root of b squared is equal to b, and the square root of 9 is equal to 3. And our answer there is b is equal to 3. Another example is to calculate the other sides of the right triangle. So this time we're going to use our acronym for TOA. So our given there are A is equal to 3, which is the opposite side of our angle, and the angle there is 30 degrees. Now, in order for us to solve for the value of C, we could use sine of 30 degrees, which is the opposite divided by the hypotenuse. And to be able to solve for the value of B, which is our adjacent side, then we're going to use tangent of 30 degrees, which is equal to opposite divided by the adjacent side. So solving for the hypotenuse, we have sine of 30 degrees is equal to opposite side over hypotenuse. So our opposite side is equal to 3, and our hypotenuse is an unknown value, which is represented by our letter C. Using cross multiplication, we have C is equal to 3 divided by sine of 30 degrees. You can solve sine of 30 degrees using the calculator. So 3 divided by sine of 30 degrees, that is equal to 6. And so the value of our hypotenuse or our C is equal to 6. Now let's solve for the adjacent side represented by our B. So using our tangent of 30 degrees is equal to the opposite side divided by its adjacent side. Substituting our values, so tangent of 30 degrees is equal to 3, which is the opposite side, and our adjacent side is represented by our B. Using cross multiplication, that would be B is equal to 3 divided by tangent of 30 degrees. Using the calculator, 3 divided by tangent of 30 degrees is equal to 5.2. Now for our hypotenuse, the value is 6, and for our adjacent side, the value is 5.2. Another way is to calculate the angle of the right triangle, using again our SOH. So this time we have our missing side, which is our hypotenuse, and even the missing angle, which is represented by our angle A. And the given that we have in the illustration are side A, which is our opposite side, which is equal to 2, and side B, which is our adjacent side, which is equal to 1. So tangent of A is equal to opposite side divided by adjacent side. So substituting our values there, so tangent of A is equal to 2 divided by 1. This time, our goal here is to get the measurement of our A as our angle. And so we're going to apply arc tangent. So that would be A is equal to the arc tangent of 2 divided by 1. Using your calculator, arctan of 2 divided by 1, or that simply means arctan of 2 is equal to 75.96 degrees. Now for us to solve for our hypotenuse, using this angle 75.96 degrees, we can use the trigonometric function of sine. So sine of 75.96 is equal to the opposite side, which is 2, divided by the hypotenuse. Now, on your own, I want you to solve for the value of the hypotenuse. trigonometric ratios of special acute angles. To evaluate the trigonometric ratios of the special acute angles, we can use the geometric method. These special acute angles are 30 degrees, 45 degrees, and 60 degrees. We have our isosceles right triangle. Isosceles right triangle is a triangle whose two sides are equal and one hypotenuse. We have also two equal acute angles. Another one is our scalene right triangle. Scalene right triangle has no sides equal. And so we could have 60 degrees and 30 degrees as the acute angles of our scalene right triangle. Isosceles right triangle could be also named as 45 degrees, 45 degrees, 90 degrees triangle. The legs are congruent and the length of the hypotenuse is the square root of 2 times the length of the leg. Our scalene right triangle could also be named as 30 degrees, 60 degrees, 90 degrees triangle. The length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is square root of 3 times the length of the shorter leg. Now let's have some more examples in finding sine, cosine, and tangent. Find the sine, the cosine, and the tangent of angle A. You can give a fraction and decimal answer rounded to 4 decimal places. So we have here the values of our three sides. So the hypotenuse is equal to 10.8. Our adjacent side with respect to this angle is equal to 6, and our opposite side is equal to 9. And so sine of A is equal to opposite over hypotenuse. So that is 9 over 10.8, and that is equal to 0.8333. For our cosine A, that is adjacent over hypotenuse. So we have 6 divided by 10.8, and that is equal to 0.5556. And for our tangent A, opposite divided by adjacent, and that is 9 divided by 6, and that is equal to 1.5. Another one, find the sine, the cosine, and the tangent of angle A. So this time we have our hypotenuse equal to 24.5, and with respect to this angle, we have our opposite side, which is 8.2, and our adjacent side, which is 23.1. For our sine A, that is equal to opposite over hypotenuse, then we have 8.2 divided by 24.5, and that is equal to 0.3347. For our cosine A, that is equal to adjacent over hypotenuse, and that is equal to 23.1 divided by 24.5, and that is equal to 0.9429. And lastly, for tangent A, that is equal to opposite divided by the adjacent, and that is equal to 8.2 divided by 23.1, and it will give us 0.3550. Now, this time we're going to find a side. Find the missing side, and you can round to the nearest tenth. So the given that we have in our illustration is the hypotenuse, which is 283 meters, and our angle, which is 24 degrees. So this time we're going to find the opposite side marked by our variable x. So sine of 24 degrees is equal to opposite over hypotenuse, and that is equal to x over 283. And so cross multiplying 283 times sine of 24 degrees is equal to x. So using your calculator, the value that we could get is x is equal to 115.1 meters. So the opposite side is equal to 115.1 meters. Finding the missing side, and you can round to the nearest tenth. So this time we have this given angle which is equal to 72 degrees and the opposite side which is equal to 80 feet. So we can use this time our tangent. So tangent of 72 degrees is equal to opposite side which is 80 degrees divided by your adjacent side which is your x. Now cross multiplying we have x times tangent of 72 degrees is equal to 80. Then we're going to divide both sides by tangent of 72 degrees. So x times tangent of 72 degrees divided by tangent of 72 degrees is equal to x. Then that is equal to 80 divided by tangent of 72 degrees. And so using your calculator, 80 divided by tangent of 72 degrees is equal to 26 feet. So our adjacent side is equal to 26 feet. Now, we're going to find an angle. So find theta round to 3 decimal places. So make sure you are in a degree mode and not radians when using your calculator. So this time we're going to find an angle which is our theta. So we have our given sides which our adjacent side and our hypotenuse. So adjacent and our hypotenuse will be using our trigonometric function which is cosine, right? So cosine theta is equal to adjacent side divided by hypotenuse which is 7 divided by 23. So this time we're going to apply our cosine. So what will be left here is our angle theta, then applying our cosine of 7 divided by 23, and that would be equal to 72.281 degrees. Now another one, this time we're going to find theta. And so the given that we have there is our opposite and our hypotenuse. So we could use sine theta. So sine theta is equal to, the opposite is 200 divided by the hypotenuse which is 400. So applying your arc sine, that would be theta is equal to arc sine of 200 divided by 400. So using your calculator, we have theta is equal to 30 degrees. In summary, when we are trying to find a side, we use sine, cosine, or tangent. But if we're trying to find an angle, we use arc sine, arc cosine, or arc tangent. Let's go to the application of trigonometric functions. We are applying our trigonometric functions in getting the angles of elevation and depression. So let's define first angle of elevation. An angle of elevation is the angle formed by a horizontal line and the line of sight to a point above the line. Angle 1, which forms by this horizontal line and this line here, is the angle of the elevation from the tower T to the plane P. How about angle of depression? An angle of depression is the angle formed by a horizontal line and the line of sight to a point below the line. So our angle 2 here was formed by this horizontal line and this line here, which is the angle of depression from the plane P to the tower T. This time, we're going to classify each angle, whether it is an angle of elevation or an angle of depression. Angle 1 is formed by a horizontal line, this line here, and the line of sight to a point below the line. It is an angle of depression. How about angle 4? Angle 4 is formed by a horizontal line and the line of sight to a point above the line. So this time, it is an angle of elevation. And lastly, we have angle 2. So angle 2 is formed by a horizontal line and a line of sight to a point above the line. So this time it is an angle of elevation. Another one, we have angle 5. So angle 5 is formed by horizontal line, this line here, and the line of sight to a point below the line. So it is an angle of depression. How about our angle 6? So our angle 6 is formed by horizontal line, this line here, and the line of sight to a point above the line, and it is our angle of elevation. Now let's have an example for our angle of elevation and angle of depression. I'm going to read our problem. The shuttle space needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the space needle is 70 degrees, how tall is the space needle? You can round to the nearest meter. So in our illustration, we are looking for the height of our space needle. So it is represented by our y. And we have here our angle of elevation. So the angle that we have is 70 degrees, and this adjacent side, which is 67 meters. So what trigonometric function are we going to use if we have this given? So we have an angle and our adjacent side. Correct. So we're going to use tangent. So that would be tangent of 70 degrees is equal to the opposite side, which is represented by our y, divided by the adjacent side, which is our 67 meters. All right. So cross multiplication, that is equal to y is equal to 67 times tangent of 70 degrees. So you can use your calculator to compute your y. So y is equal to 184 meters. And so the height of the tower from the ground to its tip is equal to 184 meters. Now let's have another problem. Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff to the nearest foot? So this time, we're going to find this distance. So that is the distance at the foot of the cliff towards the seal. So we have here our given. So the height of the cliff is 40 feet and the angle of depression is equal to 52 degrees. So what trigonometric function are we going to use? Very good. So we're going to use, again, tangent. And that would be tangent of 52 degrees is equal to the opposite side, which is 40 feet, divided by the adjacent side, which is represented by our x. So using cross multiplication, that is x equals 40 divided by tangent of 52 degrees. So using your calculator, 40 divided by tangent of 52 degrees is equal to 31.3 feet. Work your progress. Answer the following problem using the concept of trigonometric functions. You can draw a diagram and show the complete solution and circle the letter of the correct answer. For number 1, I'm going to read our problem. At a diving competition, a 6-foot-tall diver stands atop the 32-foot platform. The front edge of the platform projects 5 feet beyond the ends of the pool. The pool itself is 50 feet in length. A camera is set up on the opposite end of the pool, even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation to the nearest degree? So our choices are A is equal to 37 degrees, B 35 degrees, C 40 degrees, and D 50 degrees. Number 2. Louisa is in a hot air balloon 30 feet above the ground. She sees the landing spot at an angle of depression of 34 degrees. What is the horizontal distance between the hot air balloon and the landing spot to the nearest foot? So A is equal to 19 feet, B 20 feet, C 44 feet, or D 58 feet. And lastly, we have problem number 3. Madison looks out her second floor window, which is 15 feet above the ground. She observes two parked cars. One car is parked along the curb directly in front of her window, and the other car is parked directly across the street from the first car. The angles of depression of Madison's line of sight to the cars are 17 degrees and 31 degrees. Find the distance between the two cars to the nearest foot. So our choices are A is equal to 14 feet, B 24 feet, C 37 feet, or D 49 feet. Now you can take your time in answering these 3 problems and please write them down on the comment section below. Thank you so much for listening and watching this video. Please don't forget to like and share this to your friends and your classmates. And if you have questions, just go to the comment section below. And I hope you consider subscribing to this YouTube channel. Again, it's my pleasure to create and make video on your math lessons to make your learning journey a wholesome and fun activity. By the way, this is your Sir O. Till next time, God bless and keep safe always. Goodbye.